Okay guys, morning. We have a lesson here on some new index laws. If you've been following along in the correct order, you will have seen we've seen the addition and subtraction index laws already. Today we are looking at two brand new ones. The first one being the multiplication law and the second one being the zeroth power law. Okay, the third index law, the multiplication law, and it is as followed. So as usual guys, I'll get you to copy these down into your notebooks. When a number is raised to a power, which is raised again to a power, the powers are multiplied. So if we have a look at the example, we have the number a, it is raised to the power of n, and then it is raised again to the power of n. The result is a to the power of m times n. We have an example down here, okay? So let's have a look at the example. We have 2 to the power of 3, and then that is all, okay, to the power of 4. And the result is that we can use this law to simply multiply those powers together, okay? So if you don't mind, I'm just going to show you very quickly how I like to think about this law and to try and get it to make a little bit more sense if you're struggling a little bit with it. Alrighty, so what we might do, guys, is we might have a look at this example in some more depth. So we have 2 to the power of 3, and that is all to the power of 4. So what we're going to do is we're going to use expanded form of this to get 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 3. Okay, excuse that last little bracket there, it was a bit dodgy. Let's try it again. There we go. So, okay, we add to the power of 4. So we now have 1, 2, 3, and 4, 2 to the power of 3s. Right, now, in each of those sets of brackets, we are going to write the expanded form of 2 to the power of 3. Let's have a look. 2 times 2 times 2. Righto. Times, so that's the first set of brackets. We'll keep our brackets in to help us keep check. 2 times 2 times 2. Okay. 2 times 2 times 2. Goodness me, this is getting pretty old pretty quick. But let's have a look at how many 2's we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow, so I can write this as 2 to the power of 12. That is exactly what we got by just using the law. Okay, now you could imagine that this gets even harder to do, okay, this whole stepped out working. If we had, you know, maybe we had 5 to the power of 17 all to the power of 20. Okay, you're going to be there all day trying to write out all of those silly 5s. You're going to have quite a few. So this law always works, and it saves us from having to write out a bunch of work. Very, very powerful law, one of my favorites. Okay guys, so what we have here is a bunch of we do questions. Before I let you guys just have a crack at all of them yourselves, I might do some of the trickier ones just to give you guys a bit of an idea, a bit more of a look at how to apply this power rule. So, okay, I have 5 to the power of 6, all to the power of 2. I simply multiply those two powers and I get 5 to the power of 12. I might do the first row. So 4 to the power of 3, all to the power of 3, times the powers. 3 times 3 is 9. This one here, you could kind of break it up into 2 steps. So I might do the inside one. Alternatively, you could just do it in one big step because it is going to be 5 to the power of 3 times 3. And that is all raised to the power of 3 again. So we're going to times that by 3. 3 times 3 is 9, times 3 more is 27, okay? Similarly here, 3 times 3, okay, is 9, times minus 3 is minus 27. The rest I'll leave for you. So if you can pause the video, guys, and I'll see you back here in a little bit. We'll see how you went. Okay, so hopefully you went all right, guys. We'll run through some of the answers. We'll go down the columns this time and have a look. So the base always stays the same, right? So we have 6, and then all we're doing is this is a power raised to a power. 6 to the power of 2, all to the power of 8. Okay, we know that because of the brackets. So we're going to multiply the two powers. We get 2 times 8, which is 16. So 6 to the power of 16. Base stays the same. This is 9 to the power of 7, all to the power of 4. Multiplying those two powers together, we get 9 to the 28. And that's just basically the pattern that we follow, guys. Okay, multiplying those powers. It doesn't get too much more complicated than that when we know, okay, that it is the multiplication rule. The hard part will come in when we start to have combinations of powers, and we have to think about what rule actually applies to the situation. It does start to get a little bit tricky over here where we have a couple. Okay, so this is 7 to the power of 3 raised to the power of 4 raised again to the power of 5. Okay, so that should be what's that, 60. Okay, this one here, 2 to the power of 120, 4 to the power of what's that, 56. There we go. Tidy up these ones as well, so we just have a little negative in there. 4 to the power of minus 90, 6 to the power of, ooh, that's fun, negative 90 again, I should have saw that, and then 8 to the power of negative 16. Okay, so as I said, the tricky part is always being on the lookout for what rule applies. Okay guys, and the fourth index law, easily my favorite one because it is so nice and simple. But still some of us tend to forget this one, so I'll do my best to explain it and help us remember it. This rule states that when a number is raised to a power of 0, the answer is 1. So a to the power of 0 is 1, and that works for pretty much every number. There are a few exceptions, but we don't tend to see them, such as 0 to the power of 0, infinity to the power of 0, but a to the power of 0 is equal to 1. So, for example, 4 to the power of 0 is equal to 1. Okay, 7 to the power of 0 is equal to 1. 104,000 to the power of 0 is equal to 1. Okay, hopefully you get the idea. If it has a power of 0, we can simplify it or write it down as 1. Now, really quickly, guys, I'll do my best to see if I can convince you why this rule works like we've seen for all the other rules. So, what we're going to do is we are going to start out with a number. Let's say 10. 10's a nice number. And we're going to have a look at 10 cubed. So that is 10 times 10 times 10. And hopefully we all agree that that is 1,000. And what I'm going to do is I'm going to reduce that power by 1. So I'm going to go 10 squared. Now what I would have to do to go from 10 cubed to 10 squared, okay, let's think about it. So it would just be 10 times 10, which is equal to 100. Okay, don't think we have too many arguments there. So what I've done, if I wanted to put in a step or an operation, or what I've done to change 10 to the power of 3 to 10 to the power of 2, I would say I have divided by 10. Okay, 1,000 divided by 10 is equal to 100. Hopefully we're all pretty familiar with that. Another way of thinking about it is if we divide this by 10, we can cancel out 1 and 1, okay, and we're left with 10 times 10. Whatever way works, okay, hopefully you're convinced that 1,000 divided by 10 is 100. Let's continue this pattern, right? Let's go 10 to the power of 1. Well, that's just 10, which is just 10, okay? A little bit boring. But again, we would get there by dividing by 10. So every time, let's write some notes on what's going on. Every time I reduce the power just by 1. It is the same as dividing by the base. What's a dodgy? Let's rewrite that one. The base. Okay, that's what we're doing. So let's do it one more time. If we had 10 to the power of 1, we're going to reduce the power by 1 more. 1 take 1 is 0. Okay? So what we have in this middle row is a little bit weird, but what the result is we're going to divide by 10. 10 divided by 10. 10 split into groups of 10. How many groups? So we have 1. Okay? 10 to the power of 0 is 1. This works for any base number. Not any base number, being careful with that, but with most base numbers. Okay? So we could do this with 5, with 2s, with 3s, with 7s, pick your favorite number, and we would get the exact same thing. Following that repeated division, and we get, 7 divided by 7 is 1. Okay, 6 divided by 6 is 1. 104,000 divided by 104,000 is 1. Hopefully we can remember that and make sense. Okay, so a couple of weirdos, guys. You know the drill. If you could pause the video, have a crack at these problems yourself, and unpause when you're ready. I'll see you in a bit. Okay, guys, welcome back. We have just these really 2 quick examples here. So applying the zeroth law, my favorite law, I see immediately that I have a power of 0, so my answer is 1. Okay, this is why it's my favorite. It's so easy. 8 times 3 to the power of 0. Well, again, 3 to the power of 0 is 1. So I have 8 times 1. And I'm sure we would all agree 8 times 1 is 8. Guys, really nice lesson. We're actually here to allow you to practice those 2 new laws, okay? The multiplicative law and the zeroth law, both very important. And we'll start to see combinations of those. So make sure you're feeling very confident with those before we press on. And I'll talk to you in the next PowerPoint.